Hi everyone. In today's we are going to discuss basic concept of trigonometric functions. We have studied that the inverse of a function f denoted by f dash, f inverse, if exists, it exists when f is 1 1 and onto. F is 1 1 and on 2. There are many functions which are not 1 1 on 2 or both, and hence we cannot talk of their inverse. In class 11 we studied that trigonometric functions are not 1 1 and onto, over their natural domains and range, and hence their inverse do not exist. Here we shall study about the restriction on domain and range of trigonometric functions which ensure the existence of their inverse and observe their behavior through graphical representations. Besides some elementary properties we shall discuss, inverse trigonometric functions play an important role in calculus for their serves to define main intervals. Before going to discuss the trigonometric inverse functions, we are going to discuss trigonometric functions. There are 6 trigonometric functions which are sine theta, cos theta, tan theta, sec theta, cosec theta, and cot theta. These 6 are trigonometric functions, but here we are going to discuss the inverse trigonometric functions. Sine theta, sine inverse is written as sine inverse, cos inverse, tan inverse, cot inverse, sec inverse, and cosec inverse. Generally, inverse is denoted by -1. Like this, sine, this is -1, which is known as inverse. So it is known as a sine inverse. In trigonometric functions, there is a theta, that is known as an angle. But here in sine inverse, here it is an x. X is always a real number. X is always a real number. Actually, trigonometric functions has no inverse, but some restriction is there to make it is invertible. Such restrictions were given a graph. The graph is this. The graph, that is the x-axis, that is the y-axis, that is the graph sine 0 0. The graph passes to the point 0 0 and sine pi by 2 equal to 1 and sine minus pi by 2 equal to -1. So the graph like this pattern. Here x is the whole real numbers, and that is the domain, and that is the range. Range is -1 to +1. But in this case, the function is actually in natural domain. The function is not 1 1 and onto. Like this, if we take a point here, and it has an image also here. Again, we take a point, another point here, then we get the same image. That means one element has a many images. So so it is not 1. That's why our mathematicians has a restriction, take a restriction in case of domain, that is from this portion to these portions. In this graph, every point has distinct points. That means every x there correspondence and y. Every point there correspondence and value of y. That means 1 point we get 1 image. 1 point we get 1. That is the in this case whole graph. In this portion the graph is 1. The function is 1 1. So the range of the trigonometric functions from minus pi by 2 plus in case of sine, minus pi by 2 to plus pi by 2 in this restriction. In these portions the function sine function is 1 1 and on 2. That's why the sine function has an invertible. That means sine has a inverse functions. We can say the sine has a inverse functions. In this way all 6 trigonometric functions has a restrictions to make it invertible. Invertible, that means every trigonometric function has its inverse. If we draw a graph of inverse function, that is y equal to sine inverse x, then the graph is completely changed. That is the graph is, this graph is rotate 90 degree in anti-clockwise direction. That means x-axis become y-axis and y-axis become x-axis. The graph portion is the graph is this. If we join two graphs, that is y is equal to sine x and y equal to sine inverse x, draw in a paper or graph paper, then graph like this. That is, this is the sine y is equal to sine graphs, and this is the y is equal to sine graph, and this is the y is equal to sine inverse graphs. This graph is the image of other graphs. That's like this line. If you draw a line, that is y is equal to x, this line makes this line work as a mirror of those graphs. The one is the mirror of the other graphs. That is the graph portion. In this way we can draw all the graphs of trigonometric function. That means every trigonometric function is invertible with some restrictions. That means restriction in case of domain. The restrictions are these: the function has the functions are sine inverse. Sine inverse is domain is equal to -1 to +1, and range is equal to minus pi by 2 to plus pi by 2. This is the closed inverse. Closed interval. Closed interval means n value can take in this inverse. N values are included. That means minus pi by 2 and plus pi by 2 include in this range. Include in this closed interval. Cos inverse, domain is -1 and +1, and range equal to 0 to pi in a closed intervals. Cos, that is the restrictions. Cosec inverse are real numbers, -1 to +1, that is the open interval. In case of range, we know that cosec inverse equal to 1 by sine inverse 1 by x. That's why sine 0 0, that means 1 by 0 is not defined. 1 by 0 is not defined. That's why we can minus 0 element from these portions. That means 0 is not included here. That's why we have to write minus 0 elements. sec inverse, also the range of 0 to pi in a closed interval, but sec inverse cos pi by 2 equal to 0. That's the 1 by cos means sec. That's why cos sec 1 by cos means 1 by 0. This is not defined. That's why we have to deduct the element pi by 2 from this. That means in pi by 2 sec function is not defined. That's why we deduct it. In case of tan, range is minus pi by 2 to plus pi by 2 in an open interval. That means tan minus pi by 2 and tan pi by 2 is not defined, so excluded minus pi by 2 and plus pi by 2. Similarly, cot inverse, the range is 0 to pi by 2 in open interval. Due to cot 0 is not defined and cot pi is not defined, so 0 and pi is excluded. 0 and pi is excluded from this interval, so it is an open interval. That is the restrictions to make the trigonometric functions 1, 1 and 1, 2. That is known as the bijections. And so trigonometric function has a inverse trigonometric functions with some restrictions. Now we are going to discuss the exercise part, that is find the principal value of sine inverse 1 by root 2. That is the solutions. For this we can take sine inverse 1 by root 2 is equal to y. This implies if we interchange, then sine y equal to 1 by root 2. Sine root 1 by root 2, from the start we get sine pi by 4 is equal to 1 by root 2. That's why we have to write since sine pi by 4 equal to 1 by root 2. In place of 1 by root 2, we have to write sine pi by 2. This equal to y is equal to pi by 4 belongs to minus pi by 2 plus pi by 2. That is known as the principal value branch. Principal value branch of a sine function. So their principal value of sine inverse 1 by root 2 is equal to pi by 4. That is the required principal value of sine inverse 1 by root 2 is equal to 1 by 4. Now we are going to another exercise. Find the principal value of the cot inverse minus 1 by root 2. Solution like this. In similar way, we can find the solutions. That is, let cot inverse minus 1 by root 2 is equal to y. This implies cot y is equal to minus 1 by root 3. Cot y, this implies cot y equal to minus, in place of 1 by root 3 we can write cot pi by 3, since cot pi by 3 is equal to 1 by root 3 from the table. This implies cot y is equal to cot pi minus pi by 3. This is given from where we get that is cot pi minus theta is equal to minus cot theta. That's why we have to write minus cot theta is equal to cot pi minus theta. This implies cot y is equal to cot, if we simplification this we get twice pi by 3. That's why y is equal to twice pi by 3, which is belongs to 0 to pi, which is known as the principal value branch of cot inverse functions. Hence, principal value of cot inverse minus 1 by root 3 is twice pi by 3. If there is any difficulty, my dear students, please tell me. If there is a difficulty, I will explain again. If not, we will proceed others. Thank you. Next we are going to discuss the 2.1 exercise. This is the find the principal value of the following. And number 1, in NCERT textbooks, the number 1, sine inverse minus half. Now we have to find the principal value of the sine inverse minus half. For this solution, we can take let sine inverse minus 1 by 2 is equal to y, where y belongs to principal value of branch of sine inverse, that is minus pi by 2 comma plus pi by 2 within a closed interval. After this, we get sine y is equal to minus half. This implies sine y is equal to minus a half is equal to sine pi by 6 from the start. Since sine pi by 6 is equal to half, that's why we have to write in place of half sine pi by 6. This implies sine y equal to sine minus pi by 6, since sine of minus theta is equal to minus sine theta. That's why we get sine of minus pi by 6. After this, we get y equal to minus pi by 6, that is which is belongs to minus pi by 2 and plus pi by 2, which is known as the principal value branch. Hence, their principal value of sine inverse minus half is equal to minus pi by 6. Now we are going to next exercise, number 2. This one, it is given, find the principal value of cos inverse root 3 by 2. For solutions, we can take cos inverse root 3 by 2 equal to y, where y belongs to 0 to pi. 0 to pi comes from the principal value branch, that is known as the range of cos inverse. This implies cos y is equal to root 3 by 2. This implies cos y is equal to cos pi by 6. Since we know in previous class the cos pi by 6 is equal to root 3 by 2, that's why we have to write root 3 by 2 in place of root 3 by 2. We can write cos pi by 6. That's why we get y is equal to pi by 6, which is belong to 0 to pi, that is the principal value branch. Hence, principal value of cos inverse root 3 by 2 is pi by 6. That is the solution of the exercise 2.1, question number 2. Is it any difficulties? Please comment in my comment box. Thank you. We are going to next exercise. Next exercise, we take the exam question number 4, tan inverse minus root 3. For this question, with solutions, we take tan inverse minus root 3 is equal to y, where y belongs to minus pi by 2 to plus pi by 2, since this is the range of tan inverse. This implies tan y is equal to minus root 3. This implies tan y is equal to minus tan pi by 3, since tan pi by 3 is equal to root 3. That's why we write root 3 in place of root 3. We can write tan pi by 3. Next line, tan y is equal to tan minus pi by 3, since we know tan of minus theta is equal to minus tan theta. That means we apply these rules. That's why we get tan y is equal to tan of minus pi by 3. This implies y is equal to minus pi by 3 belongs to principal value branch, which is the principal value branch of tan inverse. Hence, principal value of tan inverse root minus root 3 is given by minus pi by 3. This is a very simple solution. It is easy. It is very easy to remember. My dear friends, please remember this. These conditions are very important for trigonometry. Next, we are going to discuss the next problem. Question number 5. We have to find principal value of cos inverse minus 1 by root 2. For solutions, let cos inverse minus half equal to y, where y belongs to 0 to pi. This line comes from the range of cos inverse. That is the surd. We get from the surd, domain and range of the inverse trigonometric function. It should be remembered. This implies cos y is equal to minus half, cos y is equal to minus cos pi by 3, because cos pi by 3 is equal to 2, so we can write in place of half cos pi by 3. Next line, this implies cos y is equal to cos pi minus pi by 3. Since we know cos pi minus theta is equal to cos theta. It is found in the class 11. That is the preliminary rules. That's next implies cos y is equal to, after calculation of this, we get twice pi by 3. Therefore, y is equal to twice pi by 3, which is belong to 0 to pi in a closed interval. That is the principal value branch of the cos inverse functions. Therefore, principal value of cos inverse minus half is equal to twice pi by 3. It is a simple question to solve, very easy. There is no difficulties. So, students are get very easy and simple. Next, we are going to next questions. Question number 6. Question number 6 is given. Find the principal value of tan inverse minus 1. For solutions, let tan inverse minus 1 is equal to y, where y belongs to their range. That is, range of tan inverse is equal to minus pi by 2 and pi plus pi by 2. That's why we have to write this. That means the answer should lies between these intervals. This implies tan y equal to minus 1. This implies y equal to minus. In place of 1, we can write tan pi by 2 from the table, since tan pi by 4 equal to 1. This implies tan y equal to 10 minus pi by 4, since tan of minus theta is equal to minus tan theta. It is found in the class 11. Then, therefore, y is equal to minus pi by 4, which is belongs to principal value branch. So, or hence, principal value of tan inverse minus 1 is equal to minus pi by 4. This is the simple questions to solve. Next, we are going to next questions. Next question, question number 7 in NCERT textbook solutions. Let sec inverse 2 by root 3 is equal to y, where y belongs to 0 to pi minus pi by 2. This pi by 2 does not belongs to in this range. That beyond y, since the range of sec inverse is equal to this. This implies sec y equal to 2 by root 3. This implies sec y is equal to sec pi by 6, because sec pi by 6 equal to 2 by root 3. So, in place of 2 by root 3, we can write sec pi by 6. Okay, my students? This implies y equal to pi by 6, which belongs to 0 to pi minus pi by 2. That is the principal value branch of sec inverse. It should be remembered. Hence, principal value of sec inverse 2 by root 3 is equal to pi by 6. That is the solution of the question number 7. Next, we are going to discuss the question number 8. Question number 8, cot inverse root 3. Solutions, let cot inverse root 3 equal to y, where y belongs to 0 to pi. This comes from range of cot inverse. This implies cot y is equal to root 3. This implies cot y is equal to cot in pi by 3. In place of root 3, we can write cot pi by 6. Since cot pi by 6 equal to root 3, which is found in class 10 from the table. This implies y is equal to pi by 6, which belongs to this interval. This is the principal value branch of cot inverse. Hence, principal value of cot inverse root 3 equal to pi by 6. Next, we are going to discuss the question number 9 in NCERT textbooks for 12th student के लिए. Question number 10 is given cosec inverse minus root 3. Solutions, let cosec inverse minus root 3 equal to y, comma y belongs to the range. Range of cosec inverse is this. That's why we write this. This implies cosec y is equal to minus root 2. This implies cosec y is equal to minus, in place of root 2, we can write cosec pi by 4, since cosec pi by 4 is equal to root 2. This implies cosec y is equal to minus, this implies cosec y is equal to cosec minus pi by 4, because cosec minus theta is equal to minus cosec theta. We use these principles. We use this formula or these properties. Thus, we get y is equal to minus pi by 4. Hence, principal value of cosec inverse minus root 2 is equal to pi by 4. Minus pi by 4. Is there any difficulties? I think it is very easy for the students. Please remember these ones, and these formulas are very important for the students to remember. There are some tips to remember this formula. Next, now we are going to discuss the next questions, that is question number 9. Question number 9, cosec inverse minus 1 by root 2. For solutions, let cosec inverse minus 1 by root 2 equal to y. Y belongs to 0 to pi, that is the range of cos inverse. This implies cos y is equal to minus 1 by root 2. This implies cos y is equal to minus, in place of 1 by root 2, we can write cos pi by 4, since cos pi by 4 is equal to 1 by root 2. Then we get cos y equal to minus cos pi by 4. This implies cos y equal to cos pi minus pi by 4. From where we get, we remember. This is the formula we get in the class 11, that is the cos pi minus theta is equal to minus cos theta. Okay? This implies cos y is equal to cos, after calculation, this we get thrice pi by 4. That's why y is equal to thrice pi by 4 belongs to 0 to pi. This is the principal value branch. Principal value branch of cos inverse. Hence, principal value of cos inverse minus 1 by root 2 is equal to thrice pi by 4. That is the simple solutions. Okay. Next, we are going to next question. Question number 3. Solutions. Let cosec inverse 2 is equal to y. Y belongs to, that is come from the range of cosec inverse x. This implies cosec y is equal to 2. This implies cosec y is equal to cosec pi by 6, because cosec pi by 6 equal to 2. That means cosec pi by 6 is equal to 2, since we apply this rule. This rule is found in class 10 or in class 11 also. Next, therefore y is equal to pi by 6, which is belongs to their principal value branch. So principal value of cosec inverse 2 is equal to pi by 6. This is the simple solution for class 12 students. Okay. Is there any difficulties? Please comment me. If there is any difficulty, please tell me. Next, we are going to discuss the next questions. Question number 11. Find the value of the following. Find the value of the following. That is 11. Tan inverse 1 plus cos inverse minus half plus sin inverse minus half. For solution के लिए we can take tan inverse 1 equal to y, where y belongs to, that is the principal value branch of tan inverse or range of tan inverse. This implies tan y equal to 1. This implies y equal to pi by 4, since tan pi by 4 equal to 1. That's why we get y is equal to pi by 4. Again, we can take cos inverse minus half equal to x. X belongs to their range. That is the range of cos inverse x. This implies cos x equal to minus half. This implies minus cos pi by 3 is equal to, in place of cos minus cos pi by 3, we can write cos pi minus pi by 3. That is the rule which is found in class 11. That's why we get x is equal to, after calculation, we get twice pi by 3. Again, let sin inverse minus half is equal to alpha. Alpha belongs to their range. That is the range of sin inverse. This implies sin alpha is equal to minus half. In place of minus half, we can write minus sin pi by 6. Since sin pi by 6 equal to half, this equal to sin of minus pi by 6. That's why we can write alpha is equal to minus pi by 6. Therefore, we can write this equation tan inverse 1 plus cos inverse minus half plus sin inverse minus half. This equal to, from we get pi by 4. This equal to pi by twice pi by 3, and this equal to minus pi by 6. Taking LCM, we get 12. After simple calculations, we get thrice pi. Here we get 8 pi minus twice pi. We get, after calculating simplification, we get 9 pi by 12. After cancelling, we get thrice pi by 4. That is the correct answer. Okay. Next, we are going to discuss the next question. very easy and simple questions. Question number 12 from NCERT textbooks. Cos inverse half plus 2 sin inverse half. For solutions के लिए we can take first cos inverse half equal to alpha, where alpha belongs to their range, that is the range of cos inverse function. This implies cos alpha equal to half. Half equal to what? Cos pi by 3. That's why alpha equal to pi by 3. Again, or and let sin inverse half equal to beta, where beta belongs to their range. That is the range of sin inverse function. Then we get sin beta is equal to half. In place of half, we can write sin pi by 6 from the table. Then we get beta equal to pi by 6. Very simple. Therefore, from the questions, we can write again cos inverse half plus 2 sin inverse half. This equal to alpha, we have already taken, plus 2 to sin inverse half, we have taken beta. Next, alpha plus twice beta. In place of alpha, we get pi by 3 plus 2. In place of beta, we can find pi by 6. So, pi by 3 plus 2 into pi by 6. After calculating, cancelling, we get 3. Pi by 3 plus pi by 3 is equal to twice pi by 3. That is the correct answer. That is the very simple questions and very easy methods. Next, we are going to the next questions. Question number 13. It is a multiple choice questions. There is a question: if sin inverse x equal to y, then answer is given. A, y lies between 0 to pi, where pi and 0 are included. Here y lies between minus pi by 2 plus pi by 2, where pi by 2 and minus pi by 2 lies between. That is the closed interval 0 to pi. This is the closed interval minus pi by 2 plus pi by 2. This is the open interval 0 to pi. That is the open interval minus pi by 2 plus pi by 2. For this multiple choice question के लिए we have to find first, we have to solve the questions for getting the correct answers. For this, sin inverse equal to y, where y, that is the sin in function, so y belongs to minus pi by 2 plus pi, because this is the range of sin inverse functions, which is the principal value branch, or that is the range. So y belongs to this interval. This is the closed interval which is written in answer, in multiple choice answer in this way. So the correct result is B. That is the very simple question. This question is very important for multiple choice. This is question very important from JEE also, JEE mains also. Thank you. Okay, we are going to discuss another multiple choice questions, and question number 14 in the textbook NCERT for CBSE students and state board के लिए. Okay, question number 14 is given tan inverse root 3 minus sec inverse minus root 2 is equal to a pi, b minus pi by 3, C answer pi by 3, D answer twice pi by 3. For correct answer के लिए we have to solve the questions very carefully, very easily, within a less time. Take tan inverse root 3 is equal to alpha, where alpha belongs to the range of tan inverse. Therefore, tan alpha is equal to root 3 is equal to tan pi by 3 from chart. Therefore, we get alpha is equal to pi by 3. And let sec inverse minus 2 is equal to beta, where beta belongs to this. And this is the range of sec inverse functions. After this, sec beta is equal to minus 2 is equal to where what sec pi by 3 from the chart, and minus sec pi by 3 can be written as sec of pi minus pi by 3 from the rule of class 11, which is already discussed. Therefore, beta is equal to twice pi by 3 after calculation pi minus pi by 3. Therefore, tan inverse root 3 minus sec inverse minus root 3, this is taken as the alpha, this was taken as the beta. After replacing alpha is equal to pi by 3 minus beta replaced by twice pi by 3. After calculations, we get minus pi by 3. Therefore, correct result is B. That is the very simple questions for examination के लिए very important. That is the class, that is the 2.1 exercise. So today we are next class we are going to discuss the properties of inverse trigonometric function. Till then, bye bye. Thank you. Okay.